A salt is a product of a neutralization reaction. It is the ionic compound that's formed. A salt formed from a strong acid, strong base, will be neutral in water. However, if you have a weak acid or a weak base, this is not the case. So we're going to look at a couple of examples to show you what happens. Okay, sodium chloride. Sodium is a positive ion. So with water, we would write out the equilibrium expression. So basically split up your salt into the cation, negative, and your negative ion, the anion, react it with water, and then see what your products are. So when we do this, we do plus water. So then this would make NaOH, and it would leave H plus. Chloride would make HCl and leave OH minus. When you're trying to figure out whether they make H plus or O minus, go to the left-hand side. Look at the charge on your ion. The ion that you form on the right-hand side has to have the same charge. So if you have a plus on the left, you form H plus ions. If you have a negative on the left, you form the hydroxide ions. Now, the big problem with these two products is that they are strong base and a strong acid. And we all know strong acids and strong bases ionize 100%. So you don't actually form these. You form Na plus, OH minus, and the OH minus and the H plus reacts with water. So really, there's no reaction. So that is why sodium chloride will have a neutral solution, because we have Na plus ions, Cl minus, and water. There's no H plus, there's no OH minus. So the salt from a strong acid, strong base is neutral. Now let's look at what happens when you don't have a strong acid or a strong base. So here we have ammonium, and we have chloride. We don't need to write out the chloride again. We've already done it right here. So we know that that is going to be no reaction. So that's an NR. But what happens with the NH4 plus? So again, when you have an H plus, you will form an H plus. In this case, we're forming the hydronium ion, the formal H plus. So we will make hydronium ion and ammonia. Because we have made H3O plus, this solution is acidic. If you have H3O plus or H plus, you have an acid. If you form OH minus, you're basic. So the cation from a conjugate acid will make the salt acidic. Okay, now let's look at potassium acetate. So we've got K plus and we've got acetate. So both of them plus water. Now, the same thing that's going to happen for the potassium ion that happened for the sodium ion, you will form a strong base, which immediately becomes its ions. So there is no reaction with the potassium ion. However, the acetate ion, we will make acetic acid. Oops. And OH minus ions. Because we made hydroxide ions, this is basic. So if you have a salt that contains a conjugate base of a weak acid, you will be making a basic solution. If you make OH minuses, you are basic. Okay, now what happens if you have salt that comes from both a weak acid, weak base neutralization? So in this case, we have ammonium and we have the cyanide ion. So plus water this will make ammonia and the hydronium ion, so it is acidic. Cn minus makes hydrocyanuric acid and hydroxide ions. So in this case, if you have a salt from the neutralization of a weak acid with a weak base, you have to compare the Ka values and the Kb values. Whichever one is larger is the one that's most predominant. The Ka value for the ammonium ion is 5.6 times 10 to the negative 10. 1.6 times 10 to the negative 5 for the Kb. So the Kb value is greater than the Ka value, so a solution of ammonium cyanide would actually be basic because you would make more hydroxide than hydronium ions. So in conclusion, if the cation is a conjugate acid of a weak base, the pH is less than 7. If the anion is a conjugate base of a weak acid, the pH is greater than 7. And if you have both conjugate acid and a conjugate base, then you compare the Ka and Kb strength to determine if acidic or basic in solution. Now buffers. Buffers contain a solution of a weak acid and its conjugate base, or a weak base with its conjugate acid. For example, you could have acetic acid and sodium acetate. So sodium acetate is your source of acetate ions. So basically, buffers follow Le Chatelier's principle. So if I add H plus to the system, so if I add H plus, the system will shift left and produce more acetic acid to use up the added H plus. If I add OH minus, then the system will shift to the right because the OH minus will react with the H plus to form water, thereby removing H plus. So the system will shift right to replace it. So this is how buffers work. I mean, you can't dump a whole bunch of H plus and OH minus, but small changes will not have an effect on your solution because the buffer uses up the quantities. So there you go. Salts can be acidic, basic, or neutral in water, and then a buffer will contain a salt containing the conjugate acid or base and its acid or base, and can adjust accordingly if you add H plus and OH minus.